Good morning and a warm welcome to all of you. I am Shriyal Sethumadhavan, the conference producer of the Council of Enviro Excellence, and I'm delighted that you could join us today for the first edition of the Power Gen ESG and Sustainability Summit and Awards 2023 Day 2. The theme of the two-day virtual conference is Shaping a Sustainable Future. We've seen a completely impactful and informative day 1, and day 2 is only going to get better. In recent years, the Indian power sector has recognized the importance of environment, social, and governance practices in driving sustainable growth. As the country strives to meet its energy needs while minimizing environmental impact and addressing social concerns, ESG has emerged as a crucial framework for guiding the power sector towards a sustainable future. Under the theme of shaping a sustainable future, leaders at the upcoming PowerGen ESG Summit, which is happening, the sessions that are going to happen today, will discuss the importance of comprehensive ESG strategies in meeting the evolving needs of society and communities. The two-day conference will provide an overview of the key ESG practices being adopted in India's power sector and highlight the transformative potentials they hold, with much of it already covered yesterday. It will culminate with a memorable award ceremony today, honoring outstanding contributions to the ESG in the industry. So, why is ESG critical to the power sector? ESG practices are gaining momentum and have become pertinent in India's power sector, driven by the recognition of their significance in achieving sustainable development goals. These practices are being deployed to achieve environmental goals, control pollution, be socially responsible, enhance governance practices. The Indian government has been proactive in promoting ESG practices within the power sector. Policies and regulations are being developed to incentivize renewable energy generation, encourage energy efficiency, and reduce emissions. But despite progress, the power sector in India faces challenges in fully integrating ESG practices due to financial constraints, technological limitations, and regulatory complexities. However, increasing awareness, collaborative efforts, and innovative solutions are poised to overcome these challenges. So, yesterday we had an informative and interactive panel discussion on environmental sustainability, social responsibility, and stakeholder engagement and innovations and technologies for ESG in the power sector, joined by experienced and knowledgeable ESG industry experts and professionals. And today we are going to have another set of discussion from the industry bigwigs experts. So, ladies and gentlemen, we would now begin with the first panel discussion of the day, focused on renewable energy integration and future outlook, opportunities and challenges in scaling up renewable energy integration. I would now like to invite our session moderator, Mr. Kaushal K Vaishnav, energy expert. Following, he will give us the lead-in note to the discussion, and then he will lead the session as a moderator. Also, a few more words about Mr. Kaushal. Mr. Vaishnav has multifaceted experience in the energy sector across business development, project management, and regulatory. He is currently working across the energy and infrastructure segments. He has been involved in EPC as well as consulting projects for national and international repute, working largely across state and central government entities. He has also worked with Fortune 500 companies on multiple projects based in Asia, Africa, and the Middle East. Introducing the eminent speakers who would be joining him for this session, Mr. Prabhu Narayan Singh, Head EHS and Sustainability, Vikram Solar. Sir, requesting you to please switch on your camera. With 3 decades of diverse industrial experience in the ESH and ESG domain, Mr. Singh has left an indelible mark on the industry. His distinguished career includes leadership roles at renowned organizations such as the Aditya Birla Group, Tata Group, FL Smith, Renew, and Vikram Solar, where he has led ESH and ESG functions. Beyond his corporate roles, he actively engages with industry associations, notably contributing to the Confederation of Indian Industries, Federation of Indian Chamber of Commerce and Industry, and Institution of Engineers India. His expertise spans ESG strategy development, international ENS studies, safety system design in accordance with ISO standards, and driving cultural transformation in EHS ESG. Moreover, he excels in digitizing EHS sustainability reporting systems, managing carbon footprints, and navigating ESG reporting standards such as GRI, CDP, TCFD, SASB, and EcoVadis. As a life member of the National Safety Council of India and a member of various industry councils, including the Institute of Directors, he remains an influential figure in the realm of ESH and ESG. Welcome next, Mr. Prashant Mathur, CEO Saatvik Solar. Requesting you to please switch on your camera. Mr. Mathur is a well-known personality in the renewable energy field with extensive expertise in the renewable and environmental industries. He is in charge of developing new business and growth strategies for the domestic and international markets. His extensive knowledge, interest, and prowess in the renewable industry have contributed to the establishment of unprecedented industry benchmarks. He's going to delve into the critical topic of scaling up renewable energy integration and will help us discover the immense potential of combat climate change, boost energy security, and drive economic growth. Please welcome next Mr. Rajan Varshney, DGM New Initiatives, NTPC Delhi. Mr. Varshney is presently heading new initiatives at NTPC, the largest power company, which is diversifying into related fields. So requesting you to please start your video. He has over 35 years experience in the energy sector and has installed an innovative wastewater treatment system in NTPC corporate office. He took initiatives in ash utilization and has designed and implemented the ERP system in NTPC in the late 90s, carrying out many innovations that have won several accolades. He spearheaded efforts for September 2020 notifications for H2HCNG as permitted fuel in India Motor Vehicle Act and safety standards of FCEVs. He's passionate about environment and sustainability and has been lead speaker at various national and international conferences. Each panel member will have 20 minutes and an additional 5 to 10 minutes with Mr. Vaishnav for discussion post their presentation. Mr. Vaishnav, requesting you to please take it forward from here and give your opening remarks to the panel discussion.
Thank you so much, Shayal, for the brief introduction and leading the way for this session. So I welcome all the esteemed panel members and the attendees today for this session, and glad that we all are here. So to basically initiate the discussions, I think you have set the tone right, Shayal. So RE integration indeed is a very, I'll say, the need of hour, because we are definitely moving ahead on the ESG and critical path. So renewable energy is taking place in or shaping the future of the country. But at the same point of time, the country is also facing certain challenges in that line. And what are the challenges? How we can overcome that? What are the multiple reports which have been suggesting us to do? How it could be helping us economically and from the technical perspectives also. In like say, there are certain measures to be taken care for the grid stability point of view as well, then the overall power evacuation scenarios. So I think these key few factors kind of cumulatively set the tone right for the RE integration. So without taking much time, I would like to request our one of the panel members, panel members, to basically present the PPT and then starting the session. And
Sure.
finally, we will look at the questions which we might be getting from the audience and take forward the discussions.
Right. So we could have Mr. Singh making his presentation first, followed by Mr. Mathur, and then Mr. Varshney will join us in the open discussion. Right. So, Mr. Singh, I'm just giving you the access to share your screen.
Yeah, thank you. Thank you, Shriyal, and thank you, Mr. Kaushal, for setting up the tone. And first of all, I would like to congratulate each one of us here and whosoever is there listening us on the occasion of this World Heart Day. And the theme of the this year is use heart for every heart. So विश्व दिल दिवस पे आप सभी लोगों को दिल से बधाई. इसके साथ let me share my screen.
Yes, we can see your screen. You could get started.
Okay, thank you very much for confirming, Shriyal. So at the outset, I would like to start with a small video, and then we'll discuss on this further.
If I'm alive and 2050 we are sitting in a similar, once they grow up, it will be very difficult for them to understand what is an internal combustion engine, because they would be driving the electric vehicles, so they may not know something that we have gone through. A lot of them are youngsters, they won't know about the cassette player. What is a cassette player? Pen drive, floppy disk. Future, there may not be petrol engine cars available. So I think it's something that needs to be enjoyed, but it's important to be very responsible also. Not to forget, I feel the electric vehicle is not the solution. How the electricity is produced is the solution. If my electric is still coming from a thermal power plant, we can't say, okay, it's green. What is important is to generate electricity that is greener and to have other sustainable things that is around when it comes to the energy aspect.
So, thank you all.
If I'm alive and 2050, we are sitting in.
Yeah. So this is itself manifestation of a success of this topic, because the leaders in all other walks of life are also talking the same thing. So we in a way have been able to take everybody along. And if you look at the United Nations Sustainable Development Goals, the goal number 7, which says ensure access to affordable, reliable, sustainable, and modern energy for all. So we, as a responsible part of United Nations, as a responsible country, we also have committed there, and we have our own nationally determined contributions. So it is very well aligned with this, and all the majorly 4 targets that were set for this Sustainable Development Goals for 2030. I will definitely, at the end of my presentation, will show where we could reach by this SDG 23 report. But let us talk more about India and the renewable energy integration in India. So some key facts about the renewable energy in India. First of all, abundance of the solar radiation across all regions in India, because we are the ones who almost all 365 days have very good morning with good solar radiance all across. And our geographic advantage, because we have one of the largest coastal belts, which is very much suitable for wind energy. The most important thing is one of the largest economy with positive sentiments. So top 5th economy as on date, and actually the highest growth rate in globally as on date. And there is a proven fact that investment in renewable infrastructure has higher yields. So this is again an advantage for us. But at the same time, and we have some good hilly terrain, which is suitable for hydropower and many other things. But at the same time, there are few limitations with the renewable energy, that is intermittency, which all of us know. It is available during the day only, and then for wind, if it is in a certain range, wind speed, then only the output would be good. We can optimize extracting wind power. And then the bigger thing is need of larger investment in building renewable infrastructure. So approximately 14 to 17 trillion US dollar would be required in between 2022 to 2070 to actually achieve net zero that we have committed at global platforms. So this is a huge amount. So this is again one fact that we need to be mindful. And then shift from current conventional power plants to renewable would need lots of consideration, such as social cost. If you look at today, we use close to 1 billion tons of coal every year, and out of which 700 million tons are being used for thermal power plants only. And still 50% plus, more than 50% of our energy comes from thermal power plants. And there are many associated social issues with it. So cutting thermal power directly would affect a lot of employment associated with this thermal power plants, and then logistics to it. Similarly, decommissioning of these plants and other environmental mitigation costs, lot many things are involved into it. So we must be mindful of these facts when we are talking of opportunities and challenges, definitely. And if you look at the opportunities, we definitely have opportunities in terms of incentivizing the uses of renewable energy over conventional energy sources. In some cases, this conventional energy is still cheaper, and actually in hard to abate areas wherein it is cheaper, conventional power is being used and conventional methods are being used, which is not very much friendly in terms of carbon emission, abating carbon emissions. The other opportunity, the big opportunity, lies in distributed generation. So if we can we can create this generation at the source, at the point of use itself, so we can avoid the need of evacuating this power and making it accessible in hardest to reach areas as well. Similarly, leveraging the advanced technology for grid integration, because this intermittent nature of renewable energy gives lots of burden to the grid, and stability is a major challenge to the stability of the grid. So, and then for this, for some technical reasons, sometimes we need to this curtail renewable energy power to make sure that we don't we don't curtail renewable energy power. We need to upgrade there as well. And then demonstrating commitment through regulatory framework. Some the other friends, other speakers would appreciate that on regulatory framework, there has been a good push in terms of PLIs for manufacturing, for green hydrogen, many other things coming up. But this is not sufficient. Looking at the quantum that we need for reaching net zero. So we need some still push. And then switching to renewable sources for commercial applications instead of grid power for our offices, for our manufacturing units and all those. Instead of using the grid power directly, we can have this through long-term PPAs and then open access. All those things need to be tried out. This is an opportunity, and we know that still lot many organizations have not moved towards this renewable power for their day-to-day operations. So this is an opportunity to address the intermittency. We need to shift to the battery storage systems, green hydrogen, pump storage systems. All these things need to be tried out so that we can ensure and commit RTC, round the clock powers. So, and many new projects are coming up bundled with all this. We have, and many IPPs have done this. We have done this while my tenure with one of the largest renewable power. So this is another opportunity. And then phasing out thermal power plants and transportation fuels, replacing with greener fuels. This is again an opportunity. And until we phasing out, what we can also think of using CCUS for power plants, cements and other. So this is another opportunity that we should look at. I know that within this short time, and it is almost impossible to capture each and every opportunities here. But yes, I am trying to touch base few of them, and I'm sorry if I forget in any important one. And we can definitely talk on those in question answer session or anytime when we can catch up. So, and then there are few challenges. And the biggest challenge would be facilitating low cost financing, because this huge money, huge investment is required between this, and most of it would be required in initial years. So to kickstart it, and then in incentivizing the end users for adopting this and offsetting their operating expenses. Until unless we incentivizing them, this uses will not get pushed up. And then availability of resource-rich sites is again because close to this more than 1,000 gigawatt for more than 1,000 gigawatts, the land, other resources sites would be required, and then it is also not wise to cut forest and then put up a solar plant there. So keeping a balance, and then there are other issues related to resettlement, rehabilitation, proximity to eco-sensitive zones, extinction threats to some of the species, are a few of the things which is actually holding up. And especially in case of larger and global investments. So a lot of due diligence is done around this, and this is the very first thing which is to be fixed out before we get all those investments, especially from global investors. Then lack of robust regulatory framework. Our friends will appreciate this ALM, this, and then phasing out it, and then giving some all those. So push and going back and forth is definitely is something which is actually holding up our investments in building this manufacturing capability within the country. And then integration with grid we need to put lot of smart grid and upgrade our capabilities to accommodate this renewable energy, which is of variable nature. And then addressing intermittency with the help of this other alternative this ways, so that we meet the demand during peak hours. So these are few things that I wanted to discuss, and I promised you to report on this, what were the 4 targets, and you can see that 675 million people still live in the dark, and 4 in 5 of them are in Saharan Africa. And the biggest thing that you would note here is the last this metric. International public financing for clean energy for developing countries continues to decline. If you look at the graph, it continues to decline, and this is the biggest worry, wherein push is required, and India is this thing. India is also facing the same thing. Unless we get this, we won't be able to push this forward with the same intensity that we need to meet our net zero. So that's all from my side. Open to any questions and all this thing when we meet again, or when we will be doing it. Question answer. Over to you, Mr. Kaushal.
Thank you so much, sir, for the nice presentation. And indeed, there were multiple points which we have learned through this presentation. So, Shreyal, I would like to take a note here. So, we would like to go ahead with the Q&A right now, or shall we take it up as we proceed ahead in the session, and before we are opening for?
I suggest let Mr. Mathur also give his presentation, and then
Right.
we can do like an open discussion with the Q&As with all the 3 panelists.
Sure, that
Yeah?
would be helpful.
Yeah, Mr. Mathur, I have given you the access to share your screen. If you could please share your screen.
Sure, thank you very much. Just a second. Is my screen visible?
Yes, if you could just go to the slideshow mode and your first slide. This is,
Okay.
yes.
Yeah, so thank you, Shreyal and Kaushal, and good morning, everyone. And thanks, Prabhu. You've given a very good presentation. So I'm also going to discuss more or less about the opportunities and challenges in scaling up renewable energy integration. So, but obviously it's little formal in nature. So I'll quickly run through the presentation. Scaling up renewable energy integration is essential for addressing climate change and transitioning to a more sustainable and low carbon energy system Obviously, there are opportunities and with this transitions, but opportunities always comes with challenges. And there are emerging technologies which I'll be talking about, which will obviously play a crucial role in the transition um, into renewable energy. So I'll start with the small one-page introduction about the company, and then why scaling is important, opportunities, challenges, and the emerging technologies. So Saatvik is leading module manufacturer with 3 gigawatt annual capacity. We have been in manufacturing for over 8 years, $100+ million turnover. We are amongst the top three in India. Consistent growth since last 8 years. So these are and our factories in Ambala. Our new plant is coming in Gujarat. We're also exporting. So a little bit about Saatvik. Now, why scaling up renewable energy is important? So you have the climate change, which is such a big issue right now. We see globally you have climate issues happening already, and every year it's becoming bigger and bigger. So I think climate change mitigation is one of the key reasons why renewable energy integration is important. Reduction of air and water pollution, energy security, and I'm going to talk about it in opportunities as well. Resilience to energy shocks. So energy security, as renewable energy is abundant, and non-renewable or conventional, there is coal and oil. Someday they will run out. So you know so then innovation and technologies, from community empowerment, resource sustainability, cost competitiveness, and renewable energy is a low carbon ecosystem. Obviously, renewable energy is job creation, and obviously, as we can already see, um, you know, India is becoming a global leader in renewable energy already. So, what are the opportunities and challenges? So, in terms of opportunities, we have reduced greenhouse gas emissions. So, scaling of renewable energy such as solar, wind, hydro, and reduce greenhouse gas emissions, which helps in climate combating. Second is the energy security. So, as you know, renewable energies are abundant. Wind is not going to run out. Solar is unlimited. So it reduces our reliability on fossil fuels and enhances our energy security. Economic growth. So renewable energy sector helps create jobs and stimulate the economy, especially in regions which has abundant renewable energy sources. As Prabhu was talking, we have a very long coastline, so wind is not a problem. We are right above the equator, and so solar, we have more than 300 days, one of the highest radiations in the world. So solar and wind obviously is no problem. The other opportunity is the distributed energy. So integration of renewable allows for distributed energy sources. So you have the dependency on centralized energy grid is not there in distributed energy, which is very good. So if there is a centralized, if there is disruption in centralized, it affects everyone. But when you have distributed, then you are generating energy on a distributed scale. Technology advancements, so emerging technologies like advanced solar panels, energy storage, grid management system, it can enhance the efficiency and reliability of energy systems. If you see some challenges, obviously intermittency is one of the challenge, because sun is available in the day, so you require advanced energy storage to support that. And so intermittency is something which needs to be worked on. Grid integration, so you have grids which are old, and today, pumping energy into those grids can be complex. So advanced grid management and smart grid is something which needs to be worked on, and it is something will take time to happen. It's not something can happen overnight. Storage and battery technology. So storage is available, but it's very expensive. So storage, as the adoption will increase, the volumes will increase, and the cost competitiveness will come. Then infrastructure. So infrastructure is an investment. Obviously, there's huge amount, trillions of dollars needs to be pumped in for the transition. So it's obviously it's competitive. It's very, very cost intensive. And obviously policy and regulatory barriers. So inconsistent policies and regulations can hinder the growth. Some of the emerging technologies, so like solar is already mainstreamed, but you have every years, 2 years, you have new technologies, better efficient products. So you have thin film solar cells, percosite solar cells, CSP, concentrated technology. So these are the new advanced technologies which are there in solar. Wind, you have offshore wind farms, larger, more efficient. So, so those are the technologies in energy storage, next generation batteries such as solid state and flow batteries, grid management and smart grids. So, which are more, can work more optimum and integrated with renewable. Hydropower enhancement, so modular hydropower systems, geothermal, then you have green hydrogen production using renewable, and then CCU technology that helps reducing carbon emissions. So capturing carbon and then uh, passing it through tubes and using it in the industrial wherein converting into energy. So in conclusion, scaling up renewable energy integration presents numerous opportunities for mitigating climate change and energy security. And obviously there are some challenges, but policy, industry stakeholders and researchers, I think we all can collaborate to accelerate the deployment of these technologies and transition towards clean energy. So thank you, and I'm available for any questions thereafter.
Thank you so much, Mr. Mathur, for the brief presentation and sharing your thoughts. So, Shreya, would like to request if we have received any questions from the attendees, and we'll take it up, and then I think we can open the forum for the discussion.
Yeah. So, Mr. Vaishnav, I suggest you can start with your discussion on the session, and as and when questions come in, I will indicate it to you.
Right, right. Thank you so much, Shreya. So, I think let's open the forum for the discussion. So, with me, it is Mr. Mathur, Mr. Varshney, and Mr. Narayan Singh ji, and our dignitaries from the CE as well. So, I welcome you all for the open discussions here. So, as the topic is our integration, and our fellow colleagues have presented their views, and taking that forward, so would like to take few notes from Mr. Varshney, sir. So, sir, please share your thoughts around it, and then I think in between we all would be pitching and would be sharing our thoughts as well. So, over to you, Rajan, sir.
Okay, good morning, everyone. And we have seen very good presentations from our fellow panelists. I would like to put my views towards addressing the challenges which these presentations have pointed out, how they can be addressed for easier and better use of energy as such, not only electricity, but as a total energy usage, we can have much more sustainable, and that will require not this much expenses also. And these things are available in India itself, and even at a very lower cost of funding, we can execute this energy transition very successfully. So in this, like for grid integration of renewable, as far as intermittency of solar PV and wind is concerned, there is no doubt. But solar is not only PV, like our presenter has also hinted on CSP. So concentrating solar power today is very cost effective, and capex is also nearly around the coal-based thermal power plants. It is around 10 crore per megawatt. And here, if we install these plants, because India is well situated, that a lot of solar energy is available here, and sunshine is available nearly all the days of the year. So we should be implementing more of CSP with storage, because storage is here thermal storage. Solar heat is stored in molten salt, and it can be cheapest storage, because here we are directly storing the heat and converting it to electricity as and when required. Instead of first generating electricity through PV or some other means, then storing it in battery, which is again imported, and a lot of jungles are cut to extract these minerals, lithium, cadmium, and other rare earths. So all this is not really, say, combating the climate change, for which we are concentrating on reducing CO2 equivalent emissions. So we are very geographically well located. We have enough sunshine, and we should go in for CSP with storage in a big way. Now the technology is quite mature. Costs have come down. Around 7,000 megawatt electricity through CSP with storage is already installed across the globe, and around 5 gigawatt projects are under execution. Many of these are in our neighboring country, China. And in last 2-3 years, around 2 gigawatt they have installed in China itself. And costs are coming down, like I told you, around 10 to 15 crore per megawatt. And no coal is to be transported, no coal is to be extracted, and our railway network can also be used for transportation of other biofuels, other things for passengers, instead of augmenting that and consuming electricity in those things like transportation or extraction of minerals. Then there is another part of it. For sustainable integration, this CSP with storage ultimately converts water into steam, and instead of coal-based boiler, this is a heat exchanger only. So this steam is running the turbine, and which is coupled with generator, and we are getting same inertia-based power, which is 24/7 renewable, firm power, dispatchable power without any intermittency. Rather, it can make the PV and wind power firm without use of batteries and without use of electrical storage. Thermal storage is cheapest storage for long-term durations. Batteries cannot store more than 3-4 hours, and their deterioration happens. In thermal storage, molten salt storage deterioration is not at all there. It can work for even 100 years. And I have calculated the energy cost also, electricity cost. This is around 2.5 to 3 rupees per unit only. And that too for 24/7 firm power. If we assume the capex to be 12 crore per megawatt for large plants, maybe around 500 to 700 megawatt or more, and hybridized for solar and wind for during the day and when wind is available, so that overall best utilization of our resources is there. Then second angle is we are installing coal-based plants or increasing our generation capacity, power generation capacity. This is because 40% of the heating cooling load is on our electricity grid. And the peak power requirement happens once or twice, or maybe for some small durations during various summer months or whatever. So we are installing those plants which are so-called conventional energy plants, coal-based thermal, and which are meant for base load, which are efficient only when run at 85% of their rated capacity or more. But we are running them at very low loads because sun is available during the day and they are very little coal-based power is required. Even hydro is curtailed, which is cleaner power. So to have the sustainable integration into the grid of renewable power, again, CSP with storage is very much required. And the heating part can be used for cooling also by vapor absorption machines. And the peak load and base load can converge, tend to converge if we can transfer some of the heating cooling load. Even these CSP with storage can cater to very high industrial temperatures also, like heat at 1000 degrees centigrade or more also, because with this we can even reach a temperature of 1750 degrees centigrade. Another advantage with this firm RE is it can reduce our cost of hydrogen production through electrolysis, because the electrolyzer has 100% CUF. Because with PV and wind, what we get is only 20 to 25% power, and that too infirm, that has to be firmed, and then our electrolyzer has to be used only during that time for green hydrogen when the renewable power is there. So this makes the less usage of electrolyzer. The capex is used only for say 5 hours, 6 hours, and here with 24/7 renewable power, we can use the electrolyzer for 100% of the time, and that reduces the cost of hydrogen. If through intermittent power we are getting say at 350 rupees per kg hydrogen, with this we can get for 200 rupees per kg, because of over a long term the electrolyzer cost is divided over larger quantum of hydrogen produced. Then with the more renewable into the grid, if we increase these intermittent so-called renewable wind and solar PV, then sustainability, it cannot be integrated without fluctuations and other things. So we need firm power in any case. So we use coal-based power, and we are installing those plants to act as base load and to meet the intermittency conditions, to overcome those intermittencies. So with the stable power like CSP and storage, and transferring some of the load to heating through heating and cooling through district heating and cooling, like many entities use both heating and cooling also, like hospitals, hotels, and then of big offices, malls, and even for domestic also through district heating and cooling, this load can be shifted and peak can be shaved off. Then there are other opportunities, like if we have renewable continuously available and cheaper, then our carbon capture also becomes cost effective, because otherwise it requires a lot of energy, and if we can't give it renewable, there is no use of capturing if we are emitting carbon while producing that electricity which is required for capture. So this makes it cheaper also with renewable energy, which is 24/7 firm. Then this CO2 is to be used for various biofuels, which otherwise those fuels would be required through petroleum products. They will require extraction of petroleum. So again, we need to integrate this renewable very effectively, and through this CSP and this we can do it. Then we have other alternatives also. When we have these biofuels like methanol, ethanol, etc., and some of these can be even made from the waste also. So that problem also gets addressed, and even hydrogen from waste can be made at less than $1 per kg even today. And all these things, hydrogen, biofuel, these are also can be used for producing power when required. And hydrogen can be through electrolysis, if we make it when extra renewable power is there, it can be stored for longer duration also, and can be reused not only for power, but also for as a feedstock for various industries like hydrogenation of oils, for direct reduction of iron ore, for various heating purposes like in steel, for making firm power through hydrogen storage without using batteries, and many other uses like various in biofuels. It can be used for sustainable aviation fuel. It can be used for ethanol for shipping and buses. So cheaper renewable power, that too well integrated into the grid, can be achieved through these means. And two more technologies I would like to highlight. One is tidal energy, which is now catching up and the costs are coming down. It is available whole day and night. Also, ocean thermal is also available 24 hours. Ocean thermal uses the temperature difference between the top of the water surface in ocean and around 1 kilometer below the ocean water, inside the from the top of the surface. So if it is around 20 to 25 degrees centigrade, at least around 20 degrees centigrade, then we can have power from it. And recently we have seen one wind offshore wind tender also coming up, but again offshore wind is also intermittent. So we should also look into ocean thermal, and when we install bigger plants, it can also become cheaper. So these are some of my thoughts, and if we have to integrate some usage of waste, then we can use even syngas. We can convert it into syngas also instead of hydrogen. So different technologies are there, and such effective technologies are there that capex can be recovered in around 2 to 3 years only. And these plants can run for, and depending on technology, some plants can run for 10 years, some can even run for 50 years. And biogas is such a thing that it is like for India, we can control the waste also, and the renewable fuels we can generate through waste also. And these can be used for our gas turbines or generators, like distributed generation we were discussing in past presentations. So even this biogas can be used for feeding into generator, gas-based generators, and or hydrogen also can be used, and we can have distributed generation also. Now I stop here and let us see what questions come up in the discussion. Thank you.
Yeah. Thank you so much, Rajan sir, for giving your brief. And indeed, it was a enlightening discussion for the insights you have shared. Indeed, we have learned a lot through those facts. So I think being an open discussion, so I would request Mr. Prabhu and Mr. Prashant also to share the insights. And parallel, I think I can put on one or two my thoughts that I think yes, the biggest challenge about RE is that the intermittent. Sorry, yeah. So once the continuity of resources is not there, the uncertainty prevails. But however, I think we cannot fill the complete gap of uncertainty which these resources cause. But however, we can look at improving the efficiencies. I think few pointers would be that improving the resource forecasting. We could work on improving the load forecasting. We could do modeling and simulation for this high renewable grids. So these things I think could help in at least putting some effort would help us in dealing that uncertainty. Apart from that, energy balancing exercises like energy storage, or as Rajan sir mentioned, that hydrogen and similar options could also give us some security in terms of energy. But yes, these technologies are still developing, and they have to shape the future. Further R&D need to be done, and apart from that, policy and regulatory support matters a lot, because until unless in the whole vehicle of this energy transition, policy and regulatory becomes the driver. So better policy, the flexibilities, the better support we get, that makes it helpful for the developers, the integrators, the product manufacturers to stick to the objective and support or continue their support to achieve the larger goals. So that is my 2 cents on the lines which Rajan sir has shared. So to you, Mr. Prabhu and Prashant, if you would like to add few pointers here.
Yeah, so what I would like to add is, obviously we are talking of technology, and we know intermittency is an issue, and new technologies are there. But I think the biggest challenge which I feel, if you see, um, in India, the electricity consumption per capita is around 1200 units. It used to be 900, today it is 1200, which is one of the lowest in the world. If you compare it with China, it is more than 6,000, and US is about 12,000. Norway and all, obviously, they are very cold countries, so they are in 40,000 something. But if we have to have, um, as our middle class is expanding, as poor are becoming, so our energy consumption per capita is going to become at least China level, has potential to go to 6 times in next, if today is China, we say we are 10 years behind. By 2030, 2032, our energy consumption is going to go at least 6 times. And I'm discounting the fact that electric vehicles are going to become, cooking is going to move towards electricity. So that share is, so the pie is going to become 6 times. So renewable energy is today, renewable energy, including hydro, is around 40%, which is amazing. But I it has to become 70% of that 6 times pie. So we have to have infrastructure to handle this kind of massive jump, which is going to happen in next 10 years. And it's not one source of energy. I think be it hydro, be it solar, be it wind, be it, green hydrogen. When I say hydro, it is hydrotherm, what do you call it? Hydroelectricity, so water. But green hydrogen, all these biogas, these all have to really contribute, and I think even that will be not enough with the kind of demand we are going to see in next 10, 12 years when the economies grow. Now, the challenge which I see is firstly, there is no solar education in India. People are not aware uh, because we are of the industry, we are aware of the renewable energy, but you go to, there's hardly any understanding of the renewable in the grassroots. So I think we are doing a very bad job right from the government to us all. We are doing a very bad job of that education which is happening. Now, if you see, we had to do 100 gigawatt of renewable by 2022. Today we are around 70 gigawatt. 30 is going to come. But if you see, most of it has come from the large utility projects. While only 60% was to come from large and 40 was to come from distributed energy, which is rooftop, C&I, residential rooftop and all. So though large utility projects are doing very good and you know, they will come, but if you see out of the 70 gigawatt, I would say very small portion of it is coming from the rooftop or distributed. So there, if we have to move towards renewable, I think you need to have some kind of a central policy which can, and stability of policy which needs to drive that part of renewable energy. And I think um, because every state has a different policy, which also keeps changing because of the grid load. And I think then there has to be something to be done on a central level to have consistency of policy across the country, so that and then how the grid handles that. I think that is a challenge. Obviously, storage will become more and more. I think government is doing a lot of hybrid projects and storage projects, but some kind of subsidies also needs to be worked out so that the adoption becomes faster, because the demand is moving much faster than what we are able to do. The demand is rapidly expanding. So already at 100 gigawatt is now 500 gigawatt. So, and I think 500 will become more, but we are looking at, I think that needs to be done. So I think, and obviously when you have rooftop, a lot of rooftops are there because people are not aware or are educated. They don't know how to use their rooftop. Not everybody has access to funds to use that rooftop. Maybe there should be a rent your rooftop policy or something wherein people who want to install may install, who want to just rent out their roof and somebody else installs and supply to the grid. That is also there. So I think all these things needs to be worked out. That is my point of view.
Yeah,
Thank you, Mr.
yeah,
Mathur.
thanks, Prashant. Actually, very pertinent point. Until unless this becomes a people movement and every household has a rooftop, we won't be able to achieve this target, because this has a lot of other advantages also in terms of no need of evacuating it further and many other things. And one thing I would like to reiterate that out of all this renewable, solar will remain the ultimate source, because and the most important source, because of its abundance in availability, eternal source of power, and actually it affects every other aspect of the energy as well. Wind is also because of the thermal radiation changes and all those things. So wind blows. So we can say that sun is the ultimate source of the power. So this is one thing. Second thing is if we look at the quantum that would be required to facilitate not only the direct solar energy, but other forms of energy. In green hydrogen, the solar is one of the important component. In many other this battery, electricity, storage, anything, the major part of it will come through solar only. So the building solar manufacturing base in India is one of the things that the country should look at. And the current policies, I would say, unfortunately, are not very supportive of it. And there are still many promotions for importing the panels from outside, all those aspects. So we need to look at it very seriously. Other than this, what I would foresee is going forward, the resource rich sites that I have mentioned, the land required for setting up that much amount of solar power may not be sufficient going forward. So we may definitely have to look at building our this grid and the transmission capabilities. And very rightly pointed out by Prashant that in many states there are different policies, and many, because of this grid capabilities, many states are not allowing open access, not allowing integration of other renewable energy and curtailing powers. So all those things need to be definitely taken care. So this is one. And the other thing is, at a larger scale, we need to look at this one sun, one grid concept that Modi ji is advocating like anything. So this is also one important aspect, because going forward, we will need it to make sure that we remain on renewable sources and we depend on renewable sources of energy. So these are the few things that I would like to definitely add. So thank you all. Yeah, over to you.
Kaushal ji, I would like to speak on two aspects. One is about the land requirement for CSP. Actually, this is much less than the PV requirement, because if we have to consider energy, not capacity addition just in megawatt hours or gigawatt hours, so it is available for 24 hours with storage, and this PV is only available during the time the sun is there, and that too intermittency is there. And also we can use about the land requirement for even PV, we can use floating solar. Now the floating solar is nearly at the same cost. The whatever is the 10% higher cost, that is met through higher generation, because solar PV functions well at 35 degrees centigrade and 25 to 35 degree, and due to water evaporation it causes cooling also. So we get higher optimized generation. Further, there is agrivoltaic solar also, where solar panels are either put on stilt type structure, where below that the farming happens, or at times bifacial solar panels are used in vertical format, just like lining of the or boundary of the field. So these are some of the aspects. And then about the capacity addition, if we see that we have around 400 something gigawatt capacity already available, but our peak load, that is hardly on very few days of the year, is 220, 230, and maximum peak has reached only 240. So we have a certain cushion, and base load is hardly 180, and that too when a lot of heating cooling load is on grid itself. So there are enough opportunities available if we do it in a planned manner without increasing our grid asset more, because grid is although wherever it is required it will be added, but we can utilize existing grid assets also very effectively if we have 24/7 renewable power with us. Because what happens with solar is today the grid transmission cost of solar and this due to these innovations which are happening, like free transfer of solar and other things, the grid is being laid, costs are capex is incurred, but this is utilized hardly 25% of the time. So CUF of the grid assets is becoming lower. Ultimately, if we can increase the availability of renewable power through 24/7 sources, then this can be addressed, and it can be cheap, available electricity can be available at a cheaper cost to the end user, because the transmission cost, which is around 80 paisa per unit today, that can be reduced to maybe 20 paisa per unit. And if the heating cooling loads and distributed power etc are there, then a lot of load can be shifted from the existing grid. Then there are connected microgrids, where what happens is whenever some resultant power is required, that is taken through the grid. Otherwise, various conglomerates themselves supply their energy requirement, and demand management is done through blockchain. These are connected. If say I have my solar installed on my rooftop and I am not using it, somebody else is using it, automatically power goes to the requirement demand area, and I am paid against that through blockchain. So these are some of the new things which are happening, and connected microgrids can help in sustainable integration into the grid without increasing the grid assets. Thank you.
Thank you, Rajan sir, for sharing your insights. So I would like to add a few points. I think my colleagues have already covered a lot on the topic. But again, so just to reiterate that, yes, I think the integration of RE with the grid has its own challenges, which we are talking about. Definitely, I think I would like to draw your attention toward one additional topic of the same nature, which is the transmission infra, which we are also talking about. We have seen multiple times that the renewable projects have been put in place, they have been commissioned, but at times the transmission infra is not available, or the infra which is already present is not capable of transmitting that much power. So additional infra is required. Those delays has caused a lot of loss of power also, right? So would like to request our my fellow members to put forward their thoughts around that topic as well. So how exactly we could tackle up those challenges, and definitely it comes up with its own challenges of policy and regulatory. So any your insights are on those lines?
Yes, and these new power plants or CSPs or PVs should be installed in a synchronized manner. Like evacuation should be planned in advance while awarding these projects, because what happens is now right of way for transmission is not available easily. And even if some part of the land where over which it has to go and it gets embroiled in litigations, it takes even 3 years. But the solar PV installation is completed in 6 to 8 months. So these issues need to be addressed in a proper way, and well planned way rather. These capacities should be called when the transmission, at least right of way, is clear, so that they don't end up in stranded capex for the time the transmission is not available. And otherwise, the connected microgrids and other things are there. And plug and play if it is given. Like today, the power plant developer has to acquire the land, ensure that evacuation is there with Gencos and transmission companies. So all this should be something like single window thing, and various responsible parties should do their job. And the developer has to install the plant and run it. That should be the job, right?
So, preferably, I think, sir, you are suggesting that the way it should go is that when we are doing the route surveys or the CA or the relevant bodies define the program for the transmission infra addition, at the same point of time, the ROW challenges could be taken care. And once I think the route has been finalized, the ROW challenges could be mitigated accordingly. And after that, it makes better sense to award those projects to any of the developers, so that within no time or without losing much time on the ROW kind of big issues, the infra could be created in a at a much faster pace. And I think it could be synchronized with the construction of the RE projects as well.
Very true.
Right. And on the same line, sir, you spoke about the energy storage parts as well. So because I think when we are talking about the availability of power for 24 hours, definitely RE alone is not going to suffice. So when we talk about energy storage systems, or in fact the hydrogen also comes into picture at that line, how we are progressing there, or how we see the future on that line, which could help us on the RE integration side also, and also to ensure the power availability for 24 hours.
Actually, I am for this CSP with storage and using heating and cooling from CST part of it, because these will be helping us in 24/7 renewable power without increasing our generation capacity to that extent, because heat load can be transferred, cooling load can be transferred of the grid. And the other thing you asked about hydrogen and all, these are all required, but thermal storage is the cheapest storage. So it should be used to the extent we are able to do it. Very soon you will find tenders. I have been in discussion with Ministry, SECI, NTPC itself, others like BHEL, REC. So, and vendors. So, a lot of momentum is getting built. You will find some tenders for this also shortly.
That's a good initiative. I think that is going to shape the future in a way that if new things are coming up and the tenders are also going to take place, that is a good news for the whole overall sector, I think. So thank you so much, sir, for enlightening with this thought. So Prashant ji and Prabhu ji, your thoughts around this T&D space and the infra in terms of the evacuation we need, or the synchronization of this RE generation with the evacuation infra. Would like to have your comments as well.
Yeah, so sure. So as previously spoken, would like to reiterate that yes, definitely the key issues that major IPPs are facing nowadays. I have been with IPPs and have dealt with it for more than 4-5 years. That this ROW transmission and then making our grid smarter, all those issues are there. So this really need to be tackled up, and this needs a huge investment. And as we know that it is not same all across the country, and I would say even going beyond country. So we need to definitely look at it. This is a must need thing to make this integrated renewable in a big way.
Thank you. Thank you. Prashant ji?
Yeah, same. I also agree. Means obviously, um, going forward, storage will be very important, because obviously grid has a certain amount of that infrastructure upgradation and all will take time. It's a lot of cost impact is there. But yes, I think storage is the way to go forward, and also hybrid projects. Um, this is what is future is also moving towards that. So I think if that is there, and grid stability and smart grids are available, then I think it will solve the purpose.
So since we have talked about this RE integration, then definitely this smart grid concept has been discussed. So in terms of the smart grid and its overall well-being or implementation, I think AI and ML is also taking place around those technologies. We are moving ahead in terms of IT practices. How, if I would request all the esteemed panel members, if you would like to share any thoughts around the smart grid integrated smart grid shaping, basically. So those new IT or technologies, or the basically AI ML kind of concepts, how it is basically helping us, and any thoughts around that?
Actually, for this, we need a distributed system operator also, one. And second, we need smart meters also, so that demand management happens and existing supplies can be utilized fully. And two more points, that while setting the targets like 500 gigawatt RE, it doesn't sound the same as 500 gigawatt of coal, because we should be considering the gigawatt hours, like I told earlier. So 500 gigawatt looks good number, but big number. But if we see that if we install 125 gigawatt of CSP with solar, or a CSP with storage, or some other ways renewable, so it needs only 125 gigawatts. That won't require that much investment. So and fulfill our 24 by 7 RE. So this is there, and our targets to different entities and our external targets should also concentrate more on gigawatt hours and not on gigawatt. Now, for meeting those gigawatt targets, companies are putting up their energy in PV and wind, which is, we know, is highly intermittent and cannot be integrated into grid without storage. So had it been like gigawatt hours, people would have concentrated more on CSP with storage. So even now the policy shift should be there, and at least the targets and the monitoring should be done in actual energy, not in this capacity addition, which lies idle for most of the time. Thank you.
Okay. So I think we are mostly reaching towards the conclusion of the session in a way, but I think we have 10 minutes of time left with us. So any extra pointers from Prabhu sir, Prashant sir, and Rajan sir from your side, or the concluding remarks, let's say it that way. If we could have 2 to 3 minutes of concluding remarks from that line, that would be helpful for our listeners as well, for the overall session.
Yeah, sure. So the most important thing that we should look at is the policy framework, regulatory framework from the government, and actually moving towards the new bids that would be coming up, as Rajanji just shared, and then a push towards this distributed generation, making sure that every household start using these technologies, shifts to renewable, would be something to look for in my view.
Hi.
Yeah, thank you. Yeah, over to you, Prashant.
No,
I
Prabhu, I
think
think some speaker is there who I think
Mr. Avinash is asking something. Can we ask him to speak out?
ट्रैवलिंग का तो आप जो है ना, आप थर्ड को
I think he's not on mute and he's speaking to someone else. Shriyal, could you please?
I am just getting him on mute. Yes.
Thank you. Yeah, Prabhuji, please continue.
I think I'm done. Over to
Okay.
Prashantji.
Yeah.
Thank
Yeah.
you.
Thank you.
So yeah, so my concluding remarks are obviously, new technologies and integration based on hybrid, and storage is something which is the future. Obviously, as Rajan ji has said, gigawatt hour is more important than gigawatt, because ultimately, uh, some of these technologies are intermittent, so they don't work 24. So how much is the utilization is very important. So that is there. But to have everything in place, I think policies and stability of policies is very important. As a central policy is very important. Some state has policies, and then they just vanish away after some time, and then new policies come in. So there's um, lot of confusion around those policies, and these are all capex projects which are very time and capital intensive, and you make capital decisions. It takes 3-4 years to actually fructify, and by the time the policy goes away, and then you're back on square one, and then again. So I think the policy and stability of policies is very important. And I think overall, as I said, solar education is something, not solar, renewable energy. As climate change is important, I think the solutions um, for handling these climate issues is also important. And I think renewable energy is one of that, wherein proper grassroots education, and how people at grassroots, or how people living in an apartment, how they can contribute towards renewable energy is also very important. So which nobody is working on it. So I think something that needs to be really looked at. Um, that is obviously my concluding remarks.
Thank you, Prashant ji. Rajan sir, over to you.
Yeah,
For concluding
actually,
remarks.
I want to add that we have to change our processes and use more efficient processes. If we use this way, like LED came previously, the incandescent bulbs were there. So, in spite of increasing lighting, we could decrease our grid load. So, such things like if we use wastewater treatment, say, we consume a lot of energy, but there are simple methods, nature-based methods available. If we do them, use them, implement them, we can have better water treatment and better reuse of water in a decentralized manner, and we can save on a lot of electricity. Similarly, there are many other processes, like I said, heating and cooling load transfer out of grid. And beauty of these new technologies is that these are available in India itself, and they don't require imports also. So it gives them an opportunity for rural employment also. Like waste is available everywhere. We can convert it into hydrogen, we can convert it into biofuels and decrease our imports. And moreover, these biofuels, when used for producing electricity or heat, they are not producing any greenhouse gas. So our overall purpose of sustainability, environment friendliness gets addressed if we implement these policies in a proper manner for our country, instead of copying the steps like West is doing incineration of their waste. That is not a good proposition for India. We have so much waste, billions of tons waste every year. Animal waste, poultry waste, household domestic solid waste, industrial waste, agro waste. Instead of burning these or keeping them in landfills, we can use them properly and cut out rather emissions of methane. Methane is 84 times more potent than CO2 as a greenhouse gas. So proper planning and proper education, proper awareness needs to be created, and we can handle these situations very effectively with our Indian technologies or Indian grown technologies and without importing much from outside. Thank you.
Thank you, Rajan sir, for your concluding remark. So I think in last, I would like to share a few insights and definitely my concluding remarks as well, which would be integrating the remarks or the insights has been shared by our fellow panelists. So the very first point is that yes, we all agree that India's demand for energy is growing very rapidly, and accordingly, the targets of 500 gigawatt or similar things are taking place. And I think our industry people or the companies or the developers or the product manufacturers, as they are the stakeholders, they are working towards that goal to achieve it. But definitely there has to be certain understandings around those topics, awareness around in the public. Apart from that, R&D related aspects or the process improvement related aspects which need to be adhered by the various players, so that we are conserving energy, we are not wasting it, and accordingly we are getting better results in terms of our applications and the operations. Second point, I would like to say that yes, growing renewables increasingly challenge the power system, because we are going to put up a lot of new RE plants or similar power production scenarios. But again, just by producing power, we are not going to mitigate the risk of losing it. So adherence to providing right evacuation infra, adding up right solutions in terms of the smart grid, that would be helpful for the overall power sector and the RE integration to help us achieve those objectives. Third one would be that yes, I think from the policies perspective, Indian states has to leverage their capabilities in terms of solar and wind, and the policy will definitely play a better role there, because until unless the policy, it should be flexible, but at the same point of time, it should be giving better clarity. The frequent changes in the policy decisions, the updates make it little difficult for each and every stakeholder to implement it, or rather we say that the time we are making up our mind to implement it, there are certain changes in the policy which actually hampers the growth, and it actually alters the plan of the developers as well at times, because we have to adhere to the policies and accordingly we have to make those shifts. So policy stability definitely is a major requirement for the sector to grow and prosper further. Mostly, largely, last one, I will say that yes, the small segment which we talked about, the rooftop solars, I think they need to be monitored and managed. The awareness around the general public at the small scale consumers level should be made available. They should be made aware of the climate change, its insights, and its various challenges which we are going to face either I'll say we are facing today or we are going to face in the future. So once that cause or once that why is clear, that why we are going to do this, then the how will also become practical. So I think that once the public is aware, that way it could be taken as a very diversified activity. But yes, that is the need of hour. And apart from that, I think certain not the R&D would not be the right word, but I think innovation in the policy would be the right thing, which we have to also keep into our mind, because when we are talking about new technologies like storage of power and hydrogen, green ammonia, or similar aspects which are evolving or emerging in nature, the policy and regulatory frameworks need to be so innovative and adaptive that they are giving us right direction, setting the right tone, and giving us the right path forward. And in a way, it leads the sector towards the achievement of the goals which our government or the nation is planning to achieve too. So, and I think yes, changes to the wholesale market and power purchase agreements. This is also an important point. I think we have not discussed too much on the PPA side, but yes, I think if we could think of removing the barriers which we face on the PPA side, whenever this is going to be interstate or intrastate kind of scenarios, So that would help us dealing with the power uncertainty. So I think again that is an extended point of policy matters only. But yes, if by summarizing to these all 4 or 5 points, I would like to give a stop to my voice. But then I think hope I am able to conclude my points as well by integrating all my fellow speakers in today's session. So over to you, Shreyal. Thank you so much.
Thank you. Thank you so much, Dr. Vaishnav, Mr. Vaishnav, for leading this session for us and the summarization at the end as well. I think we had some great presentations also at the start of the session that set the tone for the entire discussion. And of course, Mr. Varshney as well, he was with us yesterday also, and definitely a lot of knowledge coming in from Mr. Singh, Mr. Mathur, Mr. Varshney. I think experience always speaks louder. So thank you so much for the time and for joining us and for sharing all your insights. We will now move on to our next session, but certainly request you to continue joining us and listening to our other sessions, and wishing you also a great day ahead. Thank you so much.
Thank you.
Thank you.
all.
Thank you so much.
Thank you.
Okay, thank you. Bye.
Thank you.